All right, let's learn of a handy way to refer to and talk about a function. Yes, Georgia. If it's about the warm-up I cannot answer, we have moved on. So here's a question from yesterday talking about the dog barking. Again, there was a lot of different options. Okay, there's an example. Day 1, day 2, day 3. Distance measured in feet, time in seconds. It says use the given graphs to answer these questions about each of the 3 days. Okay, sorry it wasn't dog barks, this was distance from post. This was the first one that we graphed. How far away was the dog from the post after 60 seconds after the owner left? Let's answer these together. Day 1, 60 seconds. 4 feet. Day 2. 4 feet. Day 3. Yeah, that was the point we had to go through. Mentioned that yesterday. B, how far away was the dog when the owner left? Yeah, 1.5 for all of them. Again, that was the other point that we needed to go through. C, the owner returned 160 seconds after he left. How far away was the dog from the post at the time? Day 1, how far was the dog away from the post? 3 3/4. So about 3.75 feet. Day 2. 4 feet, remember he laid down there. Day 3. Half a foot, 6 inches, however you want to phrase that. How many seconds passed before the dog reached the farthest point it could from the post? Day 1. How much? No. 50 seconds. You're looking for where it hits the 5. Remember the leash was 5 feet long. Day 2? 35. Maybe a little later. 38. Day 3? 30 seconds. That dog just absolutely sprinted and just got choked by that leash. Took a couple seconds to sprint out to as far as it could. Got jolted back. Consider this statement. The dog was 2 feet away from the post after 80 seconds. Do you agree with that? Depends on the day, right? Day 3 it was? Okay, depends on the day. What was the distance the dog from the post 100 seconds after the owner left? That also depends on the day. Let's look at day 3 again. 100 seconds. How far away from the post?
More than 1/4 foot.
1.25 feet, 16 inches. However you want to phrase that. All right, a handy notation. You're going to see this quite a bit. It says, let's name the function that relates to dog distance and the time. Function F for day 1, G for day 2, H for day 3. The input of each one would be T. Use function notation. All right, so day 1. Day 1, it told us to use the letter F. So whenever you do that, whatever you are using for your notation will always come first. So day 1, I'm going to put F. Day 2 will be G. Day 3, it said H's. Okay, whatever your input is, whatever your x value is, will always go in parentheses. So for instance, we're going to use t for time, but I know the time specifically here. It says distance from post 60 seconds after the owner left, so we could just write that whole thing by saying, what is the function after 60 seconds? Owner left would of course be 0 seconds. And then the bottom one is 150 seconds. Jordan, why don't you at least have your book open and make it look like you're paying attention? You know, try to fool me at least. Day 2. Anything gonna change there? Nope. Just the letter in front, we already got that. Okay, so number 2 is the opposite of that. F of 15. What does that mean? Based on what we wrote up here.
Day 1 times 15.
It's day 1. It's not times 15 though. Remember, F of 60 meant distance from post 60 seconds after the owner left. So F15 would mean distance from post. Losing my voice. 15 seconds after owner left. Try those next 2, please.
Can you zoom in just a bit on that graph?
What graph?
Right there?
Chart?
Yeah, because I can't really see.
It's just all the same thing with a different letter in front.
Well, I was doing it. Yeah, good.
All right, so G, of course, means day 2. Distance from post, 48 seconds after owner left. And the last one would be day 3. Distance from post. What do I write now? T seconds.
Seconds after owner left.
And that's why you use a variable. It's true for any amount of time. One step further, they're going to add an equal sign. So it's given us an answer to the question as well. So what does this equation mean?
120.
This one. I don't think we got to do that example even.
40 seconds, or day 3, 40 seconds after the owner left, equals 4.6 blank distance.
Oh, you were so close. 40 seconds after owner left on day 3, the dog is 4.6 feet from post.
I got it right, I just didn't know what the feet
You said
were
blank
meters.
blank, I believe was the exact wordage.
You want us to put the day?
They? I said day 3. Owner left on day 3. Just included in my sentence. How about this one?
Day 1.
It is day 1. You could start with that on the first day. T seconds
T seconds.
after owner left.
Dog was 5 feet away from the.
Dog was 5 feet from post. So much better than blank blank. Last one. On the second day, T seconds after owner left. The dog was
D.
D feet from post. All right, question number 3, dealing with birthdays. It says rule B takes a person's name as its input, gives the output of the actual birthday. Instead of having you look some up here, I'll give you the ones that I have. Alexander Hamilton is January 11th.
Who's Frito?
I don't know. Frida, not a chip.
What are these old people?
Anybody know who Frida is?
Absolutely not.
Caleb will have to look that up for us later.
Let's
The other way gives you the date and gives you the person's birthday.
Did you look these up or?
No, this is just what the book has.
Okay, good.
And
Albert Einstein, born on Pi Day.
Is that why? Wait, did he make pie?
Sure, he ate pie.
No. Did he make the whatever math pie?
No.
Then why is he doing
Did you say why was he born that day? I guess I don't know the answer to that.
Why is it called pie then on that date?
because it's 3/1/4.
That's such a coincidence. It's usually on that day.
All right.
It was May Jemison.
That's Max.
We'll have to look those guys up as well.
It's May.
May?
It's May.
I can't read your handwriting.
Thanks, Georgia.
I'm just joking.
Frida Kahlo is a Mexican painter known for her many portraits and self-portraits and work inspired by the nature.
Of course, you looked it up. Oh my gosh, am I surprised?
All right, question number 2. If you use your name as the input to B, how many outputs are there?
2. Or 1.
1. Everybody has one birthday. But if you type in your name, how many birthday, if I type in my name, how many possible outputs will I have? 1. No matter whose name you type in, they should have one birthday.
But what if they died and they came back to life?
Everyone
Oh my gosh, Georgia.
has one birthday.
I've seen
What if
videos.
there's 2 people with the same name?
If you do it the other way, you type in a birthday, how many outputs are possible?
Just one.
Many.
Many.
Wait,
Why?
what was the second option? Oh, yeah.
Yeah. Because people can be born on the same day. Which of these is a function? Okay, to be a function,
You need your,
if I put in input, I can only have one output. I can plug in 3 to an equation and get 2 different answers. That is not a function. So which one of these 2 is a function?
First one, the one where you put your name.
Rule B, the first one. Rule B is a function.
Why is it rule B and rule P?
It's just what they came up with. I didn't name them, Georgia. One output. For the relation that is a function, write 2 input-output pairs. All right, so for rule B, I type in Honest Abe, I get February 12th. I type in Alexander Hamilton. Hopefully he's not offended by me calling him Hammy. January 11th. Last one I just want to take a quick peek at. Can you find out what the quick rule is on letter A there? Or number 1? Using the words that are in parentheses, what are they doing?
multiplying.
The amount of letters.
Amount of letters, yes. So the input would be the word, which is actually a number. Output would be number of letters in those words.
Then what is the F in front of it?
Function. How about the next one? Same words there, something different.
It's the opposite. The word 3, or the word 2. Wait.
What are they
Oh,
analyzing there?
the word 1.
Is it vowels?
It is vowels, good.
Oh my gosh.
Number of vowels. So the general function term notation is going to be right there. That is read as the f of x, or the function of x. F of x is the output, that is your y value. This is your function input. Input, output, the whole thing is your name. Basically, f of x is the same as your y. So don't let the notation scare you. And you notice that is a lot nicer than writing, the whole sentence out. Okay, take a look at your homework. I'll just make sure there's no residuals or anything. No, first 6 are pretty good. Question 7. I'll let you graph one of those. I'll let you pick. I'd like to do it as a class, so decide as a class.
A.
Sure. A.
A, you want to graph, and B, you're going to do by hand.
Yes.
Okay? So I'm assuming we're going to do elimination then. Let's just get you started on that. Which letter do you want to eliminate? X or Y?
Why?
Okay, so you need to get the Y's to be opposite signs and the same number. I'm gonna change your result. I think X will be easier since there's already opposite signs there.
Wait,
So
why-
what's the first number that 8 and 5 go into? First number 8 and 5 go into 40. So I gotta take the top times 5. That's gonna be negative 40x, negative 10y, 24 times 5. Is that $1.20? I believe. And how do I get the bottom to 40?
Times 8,
Times 8, 5 times 8.
40.
Negative 3 times 8. Negative what? 24? Times 8, right?
I thought they said 3 times.
8?
Oh, yeah, 2, not 5.
2 times 8? There you go. Now you should be able to add those and solve for y. Once you get y, plug her back in. Get x.